Before the sun existed, there was just dust and darkness. A cloud drifted through the vast night of the Milky Way, quiet, chilly, and very old. But inside that dust was everything. Each moon, each storm, every heartbeat that will ever be heard on Earth. The start of our solar system, a long time ago, before our sun started shining and before Earth had oceans, a big cloud of molecules floated peacefully in the Orion arm of the Milky Way galaxy. This space cloud was made of hydrogen, helium, and small amounts of carbon, oxygen, and iron, the remnants of stars that have died. Old supernovae spread their leftovers all over the galaxy. This stardust, once overlooked and chilly, would turn into the basic elements of everything we understand. About 4.6 billion years ago, something changed, the calm. It might have been the shock wave from a nearby supernova. Maybe it was the pull of a passing star. The calm was interrupted, no matter the reason. The cloud started to fall apart because it was too heavy, being pulled in by gravity. As it spun and collapsed, angular momentum pushed the gas and dust into a fast-spinning disk, which astronomers refer to as the solar nebula. The material was squeezed tightly in the center due to a lot of pressure, and then it caught fire. At the center of the disk, gravity pressed atoms together with incredible strength. Temperatures reached millions of degrees. Hydrogen atoms combined to form helium, giving off a burst of energy. This was the beginning of a protostar, the future Sunday. When the sun came up, it not only brightened the dark, but also transformed everything nearby. The radiation and solar winds started to push the leftover dust and gas away, creating a space for what was about to happen next. As the sun formed, the surrounding disk started to cool down, come together, and bump into each other. Small bits of dust clumped together, forming pebbles, then rocks, and eventually planetesimals. These were the basic parts that made up planets. There were many collisions, fierce, very powerful. Worlds came together and broke apart. Some combined and expanded. The messy dance of gravity and collisions formed the solar system through a process known as accretion. In just a few million years, 8 main planets began to form, and their futures were determined by how far they were from the Sunday. The temperatures were very hot near the Sunday. Only materials such as iron, nickel, and rock could last. This is the place where the rocky planets, Mercury, Venus, Earth, and Mars, started to form. They were small, dense, and rocky, eventually turning into solid worlds. Beyond the frost line, the solar nebula was cooler. Lighter elements such as hydrogen, helium, and methane could come together here, leading to the formation of the gas giants Jupiter and Saturn, as well as the icy giants Uranus and Neptune. These planets became large enough to attract thick atmospheres and create many moons, some of which might have oceans hidden beneath their surfaces. Not everything turned into a planet. Fragments of rock and metal formed the asteroid belt, located between Mars and Jupiter. Past Neptune, there are icy remnants that make up the Kuiper belt, which includes Pluto and other dwarf planets. Beyond that is the Oort cloud, a layer of icy objects that surrounds the whole solar system like a giant snow globe. Let's take a moment. All of this, from cloud collapse to full planet formation, occurred on a very large scale in the universe. If we imagine the solar system's 4.6 billion year history as a 24-hour clock, the sun would form at about 4 a.m., Earth would show up around 6 a.m., and humans would only appear at 11:59 p.m. and 58 seconds. The solar system didn't come into existence easily. It came from disorder, from flames and weight and the passage of time. A swirling storm of dust turned into stars, planets, oceans, and finally, life. Everything, including Saturn's rings and your bones, originates from the same old stardust. From the remains of dead stars, a new group of worlds came into existence. However, no member of that family stands out more or has greater influence than the one in the middle. A huge ball of fire that keeps the whole solar system together. The sun, giver of life, destroyer of worlds, and ruler of the solar system. It is not just a star, it is the star. A sphere of raging plasma so massive it commands the orbits of every planet. It bathes Earth in warmth, yet its surface burns at thousands of degrees. It gives life, and it will one day take it away. This is the sun, the fiery heart of the solar system. Roughly 4.6 billion years ago, at the center of a collapsing cloud of gas and dust, pressure and gravity collided. Atoms were squeezed into each other until something miraculous happened: fusion. Hydrogen atoms merged to form helium, releasing blinding light and unimaginable heat. This was the moment the sun was born. From a dark, cold nebula emerged a blinding inferno, our very own star, a G-type main sequence star, to be exact. But the sun didn't just ignite, it became the anchor of the solar system. The sun looks like a single blazing sphere, but it is made of layers, each more intense than the last. At the very center lies the core, the sun's engine room, where temperatures reach over 27 million degrees Fahrenheit. This is where thermonuclear fusion occurs, converting hydrogen into helium and releasing enormous amounts of energy. Surrounding the core is the radiative zone, where photons, particles of light, struggle to escape. In fact, a single photon can take up to 170,000 years to pass through this dense region. As energy moves outward, it reaches the convective zone. Here, hot plasma rises and cooler plasma sinks, creating a massive churning motion like a cosmic lava lamp. This motion gives the sun its bubbling, boiling appearance. Above this lies the photosphere, the visible surface of the sun, glowing at around 10,000 degrees Fahrenheit. This is where we observe sunspots, darker, cooler patches caused by intense magnetic activity. Just above that is the chromosphere, a reddish layer that's often only visible during solar eclipses. And farthest from the core is the corona, the sun's outer atmosphere. It stretches millions of miles into space and burns at over 1 million degrees Fahrenheit. Here, massive explosions called solar flares and coronal mass ejections burst outward into the solar system. The sun is not silent. It breathes not with air, but with a constant stream of charged particles called the solar wind. This wind races across the solar system at hundreds of miles per second, shaping a giant invisible bubble known as the heliosphere. The heliosphere acts as a protective shield, fending off cosmic radiation from deep space. It's because of this solar bubble that Earth remains habitable. But the solar wind can also wreak havoc. When these particles interact with Earth's magnetic field, they can produce dazzling auroras, disrupt satellites, damage electrical grids, and expose astronauts to high doses of radiation. The sun's mass is staggering. It holds 99.8% of all the mass in the solar system. Its gravity bends space itself, anchoring the planets in stable orbits. Without it, Earth would spiral into cold oblivion. Even Jupiter, the largest planet, is insignificant next to the sun's overwhelming bulk. This gravitational dominance is what allows the sun to govern the dance of every world around. But the sun's influence is more than just gravitational. It is magnetic, literally. Deep inside, the flow of plasma creates a powerful magnetic field. As the sun rotates, this field twists and warps, building up energy like a coiled spring. Every 11 years, the sun's magnetic field flips north, becomes south, and vice versa. This solar cycle intensifies magnetic storms on the surface, increasing the frequency of solar flares and coronal mass ejection. During solar maximum, the sun becomes a violent, unpredictable giant, a magnetic beast, lashing out into space. Despite its storms, the sun is remarkably stable for a star. It's in the prime of its life, middle-aged, steady, and efficient. Right now, it's fusing over 600 million tons of hydrogen every second. But this can't last forever. In about 5 to 6 billion years, the sun's hydrogen will run out. When that happens, the balance between gravity and fusion will collapse. The sun will expand into a red giant, growing so large that it will swallow Mercury, Venus, and likely Earth. Its outer layers will drift away into space, forming a glowing cloud called a planetary nebula. At the center of this cosmic ghost will be a white dwarf, an ultra-dense core no larger than Earth. This ember will glow for trillions of years, until it too fades into darkness, becoming a black dwarf, a silent remnant of a once mighty star. The sun is not just a light in the sky. It is the source of every meal we eat, every tree we plant, every heartbeat that ever was. It forged the conditions for life. It pushes back the cold of deep space, and it connects us atomically, energetically, and cosmically to every star in the universe. Vast and quiet, a burnt world spinning around the sun, small, strange, and overlooked by history. Long before Earth and Mars, and even before our calendar started, Mercury was already on its endless journey around the Sunday. The planet is nearest to our sun, making sunlight there over 7 times stronger than what we feel on Earth. Even though Mercury is close to the center of the solar system, it is not a hot and active place. It is quiet, no air, marked, a place of extremes where time feels still, and the only noise is the sound of old rocks bumping together in a space without a sky. Mercury is the smallest planet among the 8, being just a bit bigger than Earth's moon. However, its role in the solar system is very important. It travels around the sun in only 88 Earth days, making it the fastest planet in its orbit. If you lived on Mercury, a year would be less than 3 months long. A single day, which is one complete turn on its axis, would take almost 59 Earth days. The outcome? A planet where the sun seems to rise slowly, stop, go back, and then set again. This is an optical trick caused by Mercury's oval-shaped path and its slow spin. Mercury's surface is marked by craters that reveal its history. Mercury doesn't have a way to change its surface like Earth does. Earth refreshes itself through erosion, weather, and plate tectonics, but Mercury lacks these processes. It doesn't have an atmosphere that is thick enough to shield it from space debris. The surface has many impact craters, including the huge Caloris Basin, which is one of the largest in the solar system. It was created by a big collision billions of years ago. When the asteroid hit, it caused strong shock waves that traveled all around the planet, changing the landscape on the other side. Mercury has very little atmosphere, so its surface temperatures change dramatically. On the side that faces the sun, temperatures can get as high as 800 degrees Fahrenheit, 430 degrees Celsius. That's hot enough to melt lead. At night, without an atmosphere to hold in heat, those surfaces can drop to a very cold negative 290 degrees Fahrenheit, negative 180 degrees Celsius. It's a location where ice can be found in dark craters at the poles, even when the equator is hot from the Sunday. Even though Mercury is small and looks lifeless, it has a magnetic field, which is uncommon for rocky planets. Scientists think it comes from a partly liquid iron core that is still moving below the surface. Mercury has a surprisingly large core compared to its size, which accounts for about 85% of its radius. This suggests a rough history, maybe from a crash that removed many of its outer parts, revealing a large metal core. One interesting thing about Mercury is its silence, both in a literal sense and a deeper, metaphorical way. It's a planet that gets sunlight first, but shares only soft hints of its own tale. For a long time, Mercury was mostly overlooked. Old civilizations were aware of it, including the Babylonians, the Greeks, and the Romans. They named it after the fast messenger god, Hermes or Mercury, because of how quickly it moved across the sky. For a long time, it was just a tiny dot in the sky, too small, too near the sun, and too difficult to examine. Things shifted in the middle of the 20th century. In 1974, NASA's Mariner 10 spacecraft was the first to visit Mercury. It flew by the planet 3 times and showed us its damaged, strange surface. In 2004, the Messenger mission was launched. It reached Mercury's orbit in 2011 and gave us detailed maps, gravity readings, and information about its minerals. The findings were unexpected. Under the usual craters and rocks, there were signs of old volcanic plains, frozen water tucked away in polar shadows, and a lively exosphere, a light layer of atoms pushed off the surface by solar radiation. Messenger found clues suggesting that Mercury may still have some geological activity. Tectonic cliffs, known as lobate scarps, extend for hundreds of miles across the surface. They were created as the planet gradually cooled and shrank. The cliffs show that Mercury is still getting smaller and changing even now. Slow, not too loud, but steadily. Mercury doesn't have moons, no rings, no atmospheric storms. It doesn't have the impressive size of Jupiter, the rings that Saturn has, or the fascinating stories associated with Mars. In its calm and quiet state, it has a special role in the universe. Being the closest planet to the Sun, it acts like a watchful guard, a hot observer that has witnessed more sunrises than any other planet in our solar system. It reminds us that size does not define significance, and that silence can sometimes carry the most ancient of stories. Venus, Earth's hot twin, a mirrored world, tainted by its own air, looks great from a distance, dangerous when near. From far away on Earth, Venus looks beautiful, a gentle shining ball that frequently appears in our sky right before the sun comes up or after it goes down. They named her after the goddess who represents love and beauty. In early telescopes, she shone brightly like a jewel, smooth, mysterious, and covered in clouds. For a long time, astronomers thought that behind her white clouds, Venus could be a beautiful place, possibly filled with oceans and maybe even forests. However, beauty can often be misleading. Venus is about the same size as Earth. The diameter, mass, and gravitational pull are very similar. It's often referred to as Earth's sister planet, or sometimes her twin. Earth is like the sibling that created life, while Venus is the one that lost it all. The clouds, looking beautiful from a distance, are filled with carbon dioxide and sulfuric acid. The surface is not directly reached by sunlight. The atmosphere is very thick, over 90 times the pressure of Earth, so being on the surface of Venus would feel like being 1 mile underwater. Temperatures rise above 900 degrees Fahrenheit, 475 degrees Celsius, which is hot enough to melt lead. Venus is the hottest planet in the solar system, even though Mercury is nearer to the Sun. What led to this terrible change? The answer is found in Venus's history. Venus probably started out with oceans and a gentle climate, similar to Earth. But something changed everything. Some scientists think that strong volcanic activity let out a lot of carbon dioxide, causing a runaway greenhouse effect. The oceans couldn't cool down the surface, so they turned into steam, which trapped even more heat. In the end, the planet faced a serious heat disaster. The water disappeared. The temperature increased. Venus turned into a hot furnace with no way out. Venus spins very slowly. It takes 243 Earth days to complete one full turn. Venus takes 225 Earth days to orbit the Sun, which means a day on Venus is longer than a year. Interestingly, Venus spins in the opposite direction of most planets, causing the Sun to rise in the west and set in the east. It's not clear why this happened, but it could be due to a big collision in the planet's early days or the long-term pull of the Sunday. Venus has a dry and rocky surface with large volcanic plains scattered across it. Many huge volcanoes, some as big as whole countries, stand out in the landscape. Mount Mons is the tallest volcano on Venus and one of the highest mountains in the solar system. There aren't any rivers or lakes. There are no plate tectonics like those found on Earth. The crust seems to melt and come back up regularly, like the planet refreshes itself with flows of lava. Craters are uncommon. The thick atmosphere burns up most meteoroids before they hit the ground. The smooth surface indicates that Venus went through a major resurfacing event where almost all of its land was wiped out and covered by volcanic flows. If this is correct, it suggests that the surface is quite young, even though the planet itself is very old. Next, we have the atmosphere. Thick clouds move quickly with strong winds that can go over 200 miles per hour, 320 kilometers per hour. The winds move quickly through the upper atmosphere in a process known as superrotation, making a complete trip around the planet in only a few days. But down below, close to the surface, the air hardly moves, a strange mix of calm and chaos. In the 20th century, there was a strong belief that Venus could be explored, just like the Moon or Mars. However, Venus turned out to be a difficult place for spacecraft. In 1967, the Soviet Venera program started a series of missions to go through the planet's clouds and reach its surface. The initial landers were damaged, melted, or stopped working within minutes. In 1981, Venera 13 was successful. It returned color photographs from the surface, the first and only ones like it. The pictures displayed a barren area filled with broken stones beneath a yellow-orange sky. There are no oceans, there are no forests. It's just really hot, the air feels sharp, and everything is quiet. Even though it's a harsh place, Venus still fascinates scientists. Some people have suggested that there was volcanic activity just a few decades ago. Some researchers think that tiny life forms might be found high up in the atmosphere, where the temperatures and pressures are similar to those on Earth. A study in 2020 found traces of phosphine in the upper clouds of Venus, which could suggest the presence of life. People are still discussing the discovery, but it has brought back interest in our overlooked twin, the living stone. A planet full of life, moving, changing, and bustling with activity in the emptiness of space. From space, Earth looks amazing. Deep oceans and white clouds swirl together, covering a blue and green canvas. This is the only planet that we know has life, the one world, in all the endless darkness, that is filled with birds singing at dawn, that sounds with crashing waves, and that shines with the warmth of human cities at night. Astronauts have called it delicate, stunning, and special. What makes Earth special is not only its appearance, but also its functioning. The Earth goes round the Sun at an average distance of 93 million miles. This area is known as the habitable zone, which is just right for liquid water to be present. If we get any closer, our oceans will start to boil. If they go any further, they will freeze. Distance by itself doesn't ensure a world can support life. Venus is about the same size and orbits at a similar distance, but it's a very harsh environment. Mars is chilly, but it still has some warmth nearby. No Earth's magic consists of various factors that are layered and connected to each other. Begin with water. Earth is mostly covered in water. Around 71% of its surface is ocean. Water helps control the climate, powers storms, breaks down minerals, carries nutrients, and is essential for life. Life has changed from tiny single-celled organisms to large whales all around, inside, and because of this liquid element, Earth's oceans are here thanks to another important factor, the atmosphere. The atmosphere is made up of nitrogen, oxygen, and small amounts of other gases such as carbon dioxide and argon. It maintains temperatures that we can live in, blocks harmful sunlight, and provides the oxygen we need to breathe. The blue sky happens because sunlight scatters through its molecules. It serves as a reminder of its presence, even when we forget it's there. The atmosphere needs other things to function properly. Underneath us is another amazing thing, plate tectonics. The Earth's crust is made up of large plates that move around on top of a hot liquid layer beneath them, much like pieces of a puzzle. This process recycles carbon, causes volcanic activity, creates mountains, and helps stabilize the climate through the long-term carbon silicate cycle. The Earth is always changing, breaking apart and coming together, pulling down ocean floors and raising up continents. It is active in terms of geology. The magnetosphere is an invisible shield created by the spinning liquid iron core of the Earth. The magnetic field pushes back the strongest parts of the solar wind, stopping our atmosphere from being taken away, like what happened on Mars. It helps compasses find direction, creates beautiful auroras at the poles, and keeps all life on the surface safe. Above us is the moon, Earth's constant friend. Our moon is bigger than most moons in the solar system when you compare it to Earth. This size ratio keeps Earth's axial tilt steady, which gives us consistent seasons and a fairly stable climate. The moon's gravity affects the oceans, causing tides that have changed coastlines, helped animals migrate, and impacted human culture for thousands of years. Earth is more than a planet. It is a system that supports itself and constantly changes, involving chemistry, physics, and biology. The biosphere, which includes all living organisms, helps keep the planet balanced. Forests take in carbon and release oxygen. Microbes help break down nutrients in soil and oceans. Coral reefs keep coastlines safe and support various ecosystems. Life thrives here. It forms the Earth. Life exists everywhere on Earth, from the Amazon rainforest to the polar ice caps, from the deepest ocean trenches to the highest peaks of Everest. Among all living beings, one species stands out for gazing at the stars, humans. We've mapped stars, walked on the moon, and sent our machines to the far reaches of the solar system, all while living on a thin layer above hot rock, breathing air so delicate it would disappear in a vacuum. However, Earth is also at risk. The balance is fragile. The atmosphere that supports us can be disrupted by too much carbon. The oceans that support life can also flood cities. The tectonic plates that shape continents can also cause earthquakes and volcanic eruptions. Earth is still developing. It is an ongoing story. Despite its energy and strength, Earth is uncommon. Out of the thousands of exoplanets found, none are exactly like it. Some are very warm, while others are quite cool. Some are filled with gas, while others are stuck in time. Earth is, as far as we know, the only planet that has life. And not only tiny living things, but life that creates telescopes, thinks about time, makes music, and dreams of the stars. The world that was once wet. A planet that tells of a time when water ran and the skies might have been blue. Mars feels strangely familiar. It orbits farther from the sun than Earth, but it seems like the easiest world to reach beyond our own. The rusty red color has sparked myths, stories, and science fiction for many years. Mars, named after the Roman god of war, has often been seen as harsh and foreign, yet it is also closely linked to our future. As we explore its history, we start to see that Mars might not have always been as cold or as lonely as it is now. Mars is roughly half the size of Earth, and its surface gravity is only 38% of what we experience here. A person on Mars could jump much higher, carry more weight, and feel lighter, but living there is quite challenging. The air is very thin, mostly made of carbon dioxide, and has less than 1% of Earth's pressure. This means there is no air to breathe and not much protection from the cold. At night, temperatures can fall below negative 100 degrees Fahrenheit, negative 73 degrees Celsius, even close to the equator. However, there are many indications that Mars used to be quite different.
Check out the scenery. The planet has dry river valleys, old lake beds, and thin layers of sediment, clear signs that liquid water used to flow freely on its surface.
Deltas and shorelines exist, along with erosion patterns and minerals that only develop when water is present. A long time ago, Mars might have had lakes and possibly oceans, a water cycle similar to ours. At the center of Mars is a question: what happened to the water? Scientists think that in the past, Mars had a thicker atmosphere, which was shielded by a global magnetic field. This shield keeps heat in, so water stays liquid. However, as time went on, things shifted. The planet might be smaller, which could have made its core cool more quickly than Earth's. Mars lost its magnetic field because it doesn't have a molten core. Without that protection, solar wind from the sun started to remove the atmosphere, one molecule at a time. As the air got thinner, the temperatures dropped quickly. Water turned into ice or disappeared into space. Mars gradually changed from a world that could have supported life into the dry, empty desert we observe now. The past is not completely gone. There are large amounts of water ice hidden below the surface, particularly close to the poles. Recently, orbiters have found what could be lakes of liquid water hidden under layers of ice and dust, protected from the tough conditions above. If confirmed, these might be the best spots to look for microbial life. The land is big, powerful, and impressive. Mars has Olympus Mons, which is the tallest volcano in the solar system. It is more than 13.6 miles, 22 kilometers tall, making it much bigger than Mount Everest. The base is as big as the whole state of Arizona. Close by is Valles Marineris, a canyon system that is so deep and wide that it makes the Grand Canyon seem like a small crack in the ground. If it were on Earth, it would reach from New York to Los Angeles. Mars has seasons, dust storms, polar ice caps, and a day known as a sol, which is 40 minutes longer than a day on Earth. It feels like a chilly version of our own world, one that has enough in common to spark our imagination. People have not walked on Mars, but we have been studying it for many years. Rovers such as Spirit, Opportunity, Curiosity, and Perseverance have moved across the surface, drilling into rocks, examining soil, and looking for evidence of ancient life. Orbiters have created detailed maps of its surface, and landers have examined its weather and geology. Every mission provides fresh information and raises new questions.
Is it possible that Mars could have supported life long ago? Some scientists think that microbial life might have developed during the planet's wet period, living in hot springs or hidden beneath sediments.
Life might have started at some point, and it could still be around today, hidden deep underground, safe from radiation and cold. Mars is more than just a planet with a history. It is key to our future vision. Space agencies worldwide, like NASA and SpaceX, are focused on sending humans to Mars. The challenges are big, the distance is far, the radiation is strong, and the absence of atmosphere makes landing safely a tricky issue. The dream continues to create homes, grow food, and eventually change parts of the Martian surface. Mars could be our next home, even if it takes a long time, like decades or centuries. Maybe that's what makes Mars so interesting. It is at a point where memory meets potential, where the past and future come together. It tells us that planets can change, climates can fail, oceans can disappear. It quietly asks us if we are prepared to learn from its silence, or if we will just repeat it. Ceres, Vesta, and the Broken Kids, a space between planets, where the sounds of lost worlds linger quietly. A belt is located between Mars and Jupiter, not made of cloth or leather, but made of stone. There are millions of pieces, from small rocks to tiny moons, that go around the sun in an area called the asteroid belt. For some, it's just trash. For some, it is a collection from space, a display of the solar system's first materials, preserved over time. To planetary scientists, it represents more than just a view. It's a glimpse into what might have happened. This belt didn't always have to end up as a graveyard. A long time ago, in the solar system, the area between Mars and Jupiter was crowded with planetesimals, small rocky pieces that were on their way to becoming a full-size planet. But gravity had different ideas. Jupiter's strong gravity, as it was becoming a gas giant, disturbed the area so much that the material couldn't come together properly. Rather than coming together, these fragments crashed into each other, broke apart, and spread out. The outcome was not a planet, but a group of shattered worlds. Two fragments stand out: Ceres and Vesta. These are not just space rocks, they are the building blocks of planets. Partially formed, partially forgotten, Ceres is the biggest object in the asteroid belt and is so large that it is considered a dwarf planet. It accounts for almost 1/3 of the total mass of the asteroid belt. Ceres was found in 1801 and was initially considered a new planet. As more objects were found in the same area, its status changed, and it eventually became part of the dwarf planet group along with Pluto. Ceres is round because of its gravity and is about 600 miles, 940 kilometers wide. What makes Ceres really interesting is what is underneath. NASA's Dawn spacecraft found bright spots in impact craters, shiny deposits of salt and ice that are a bit of a mystery. These bright areas might be connected to cryovolcanism, which is when salty liquid water sometimes comes up from below the surface and then freezes. Ceres may still be active in terms of geology. More and more signs suggest that a salty ocean beneath the surface used to exist, and it might still be found in some hidden areas today. If that's the case, Ceres is a very promising place to look for microbial life outside of Earth. Next, we have Vesta, the second largest object in the belt, but very different in character. Vesta is a rocky and worn-out body, looking like a piece of a bigger world, while Ceres is icy and smooth. Vesta is about 330 miles, 530 kilometers wide, and isn't perfectly round. It has a huge crater near its south pole that is over 300 miles wide and goes deep into its core. The force that created it was so strong that it sent debris flying into space. and some of that debris eventually fell back to Earth. That's correct. Researchers have found Vesta meteorites in collections on Earth. Vesta is a leftover from what could have been a complete planet. It has different layers, a core, mantle, and crust, similar to Earth. However, its journey was stopped. Collisions damaged it, marked its surface, and left it hanging between becoming something better and falling apart. The asteroid belt contains a variety of objects, including carbon-rich C-type asteroids, metallic M-types, and silicate-rich S-types. Some are just a few meters wide. Some go on for a long way. Most have uneven shapes, shaped by bumps and the passage of time. They move around the sun in a loose and spread out way, not tightly grouped like in science fiction movies, but still risky for any spacecraft trying to go through. The asteroid belt was seen as empty and not very significant for a long time. Now, it is seen as one of the most important sources of knowledge in the solar system. These rocks are ancient fossils from the beginning of the solar system, pieces of original material that never fully became planets. They hold hints about the early chemistry of the solar nebula and maybe even how water and organic materials were brought to Earth. Some asteroids have caught interest for another reason: resources. Some metallic asteroids contain a lot of platinum, iron, nickel, and rare earth elements. In the distant future, mining asteroids could become possible, making the asteroid belt accessible for both science and industry. But besides the worth of minerals or data, the belt provides something more, a story that brings humility. This is the story of a planet that never existed, of dreams held back by reality, of bodies that came together, bumped into each other, and then stopped moving. It shows us that not every path goes to a planet. The solar system has more than just places to visit. It has many possibilities to consider. The giant leader, a huge world that is hard to understand, a guardian, a destroyer, and the old gatekeeper of the solar system. Jupiter doesn't just go around the sun, it has a sort of deal with it. It's really huge, more than 318 times heavier than Earth. That its center of gravity with the sun is actually just above the sun's surface. This is more than a planet. It is a huge presence, a giant in every way you can think of. The Romans gave it the name of their chief god. In every myth, it was the most prominent. In the solar system, that title is deserved. Even if you put all the other planets together, Jupiter would still be heavier than them all. It can fit more than 1,300 Earths inside it. The magnetic field of this planet is the biggest and strongest among all planets. If it were visible, it would look twice the size of the full moon in our night sky. It's a world of highs and lows, of movement, of strength, a place where physics is tested to the max. Jupiter is mostly made up of gas. There isn't a firm ground to walk on. Under its cloud tops, there is a thick atmosphere, mainly made of hydrogen and helium, the same elements found in stars. As you go deeper, the pressure rises quickly. Hydrogen, which is usually a gas, can be compressed into a liquid that acts like a metal. This liquid conducts electricity and helps power the planet's strong magnetic field. At the center, there might be a solid ball made of rock and metal, or maybe not. No spacecraft has ever observed it. The truth is covered by heavy pressure and constant storms. When we talk about storms, Jupiter has the most well-known one in the solar system, the Great Red Spot. A huge storm, bigger than Earth, has been going for at least 350 years, and maybe even longer. The winds can go as fast as 400 miles per hour, 640 kilometers per hour, moving in a red spiral of disorder and strength. Jupiter's atmosphere is full of movement, with clouds that travel at various speeds and directions, showing stripes of white, brown, red, and orange. Jupiter's biggest impact is its gravity, the protector of the inner solar system. Its strong force attracts or pushes away comets and asteroids, protecting Earth from many impacts and sometimes sending a few straight toward us. If it weren't for Jupiter, Earth's story could have ended before it even started. Jupiter is not just a protector, it is also a sculptor. The gravity of this object formed the asteroid belt, changed the paths of early planetesimals, and might have even pushed Uranus and Neptune far out into the solar system. Next, let's talk about its moons. Jupiter is not just a big planet, it has its own system of moons and features. It has 95 confirmed moons and more are being discovered, making it home to some of the most interesting places in the solar system. Io is the most active volcano in the universe. The surface changes all the time due to strong eruptions, showing colors like yellow, red, and black from sulfur compounds. Volcanic plumes extend hundreds of kilometers into space, driven by the strong pull of Jupiter's gravity. Next is Europa, a flat, icy planet that might have an ocean hidden under its frozen surface. Scientists think that this ocean beneath the surface has more water than all of Earth's water put together, and where there is water, there could be life. Europa is now a leading focus for future exploration because it might be a second place where life could exist. Ganymede is the biggest moon in the solar system. It's larger than Mercury and has its own magnetic field, which is unique among moons. Its icy surface might cover another ocean, sitting below old rocks and frost. Callisto is the farthest of the major moons. Its surface shows many impacts from the early solar system and has remained mostly unchanged for billions of years. The Galilean moons, which Galileo discovered in 1610, are only the start. Jupiter has some lesser-known moons that are irregular and are thought to be captured asteroids, along with icy bodies from farther out that travel in unusual, stretched-out paths. Over time, spacecraft such as Pioneer, Voyager, Galileo, and Juno have uncovered more details about Jupiter. Juno has looked through the clouds with microwave and gravity measurements. It has shown that Jupiter's bands go deep into the atmosphere and that its core might be less solid than previously believed, a mix of heavy elements that have changed over time. Jupiter is more than a planet, it's a key part of the solar system's history. Some ideas propose that it might have developed nearer to the Sun and then moved outward, causing smaller objects to spread out behind it. Some suggest that it served as a barrier, stopping ice-rich material from getting to the inner planets. This might explain why Earth formed as a dry planet, later receiving water from comets and asteroids. The ruler of the rings, a place filled with golden colors and gentle rings, where beauty hides strong planetary forces. If Jupiter is the king, then Saturn is the artist, beautiful, shining, and known for its most famous characteristic, its rings. This is a world that has fascinated people for many years. In 1610, when Galileo looked at Saturn through his basic telescope, he noted that it appeared to have ears. He had trouble explaining what he was looking at. What he saw was something no one on Earth had ever seen, a planet with a crown of ice. Saturn is the second biggest planet in our solar system, measuring around 75,000 miles, 120,000 kilometers across. Similar to Jupiter, it is a gas giant made mainly of hydrogen and helium. And like Jupiter, it does not have a solid surface. Saturn is much less dense than other planets. It is actually the least dense planet in the solar system. If you put Saturn in a big enough ocean, it would float. The outer atmosphere has stripes of light yellow, beige, and gold, gentle and understated when compared to Jupiter's bold colors. However, its calm look can be misleading. Saturn has strong storms and powerful winds. The winds on Saturn can go as fast as 1,100 miles per hour, 1,800 kilometers per hour, which is quicker than any hurricane on Earth. At the North Pole, there is a strange and fascinating shape, the hexagon. The six-sided jet stream was first seen by the Voyager spacecraft and later examined by Cassini. It is unique in the solar system, covering more than 20,000 miles, 32,000 kilometers. It creates a nearly perfect geometric shape that spins with the Earth, a puzzle made of gas and wind. In the middle, there is a huge storm, a dark swirl much larger than Earth. What people often think of when they hear about Saturn are its rings, bright, delicate, and complex. They extend for 175,000 miles, 282,000 kilometers, from the center of the planet, but are usually just 30 feet, 10 meters thick. The rings are mostly made of water ice, along with some rock and dust. They reflect sunlight so well that you can see them with even small backyard telescopes. These rings are split into 7 main groups, labeled A to G, with spaces and separations in between. The Cassini division is the most well-known feature. It is a dark gap that separates the A and B rings, formed by the gravitational pull of Saturn's moon, Mimas. Even though Saturn's rings are beautiful, they won't last forever. They are young, maybe just 100 to 200 million years old, and they are disappearing. Micrometeoroid impacts and Saturn's gravity gradually draw the ring particles closer in a process called ring rain. Over time, the rings might completely vanish, leaving Saturn without them as they drift away into space. Saturn, similar to Jupiter, has a group of moons, orbiting it more than 140 confirmed and provisional, each with its own unique characteristics. Some are empty and have many craters. Some are cold and hard to understand. Some are truly interesting objects in the whole solar system. Titan is Saturn's largest moon. It is bigger than Mercury and has a thick orange atmosphere. It is the only moon in the solar system that has a significant atmosphere. Titan has lakes and rivers made of liquid methane and ethane instead of water. The landscape looks a lot like Earth, featuring dunes, rain, and weather systems, but the temperatures drop below negative 290 degrees Fahrenheit, negative 179 degrees Celsius. Next is Enceladus, a small icy moon that measures around 310 miles, 500 kilometers in diameter. Enceladus was once believed to be inactive, but in 2005, scientists were surprised when the Cassini spacecraft detected water vapor shooting out from cracks in its southern hemisphere. This showed that there is a hidden ocean beneath its icy surface. The geysers have organic compounds, which means Enceladus could be a place where life is possible or even where simple life exists. It is now a leading focus in the search for alien life. Other moons like Mimas, Rhea, Iapetus, and Hyperion each add their own parts to the story of Saturn. Mimas resembles the Death Star. Iapetus has one side that is very dark, like coal, and the other side that is very bright, like snow. The system has a lot of contrasts and mysteries. The Cassini-Huygens mission, which started in 1997, greatly improved our knowledge of Saturn. Cassini orbited Saturn for 13 years, taking amazing pictures and studying the rings, moons, and atmosphere. In 2005, the Huygens probe was the first human-made object to land on Titan sending back images from the surface of this faraway, misty world. In 2017, Cassini was intentionally sent into Saturn's atmosphere to prevent any contamination of its moons, a dramatic and fitting conclusion to one of NASA's most successful missions. The Leaning Enigma, a world turned sideways, quiet and blue, keeping secrets hidden under its still surface. Uranus is one of the largest planets in the solar system and is known for being quite mysterious. From Earth, it looks like a light blue dot far away, calm and easy to overlook. However, when you look closely, it surprises you in many ways. Uranus is different from other planets because it spins on its side, tilted at an unusual angle of 98 degrees. Its axis is almost in line with its orbit, which means it rolls round the Sun like a barrel. This is not just a fun fact, it makes a big difference. Uranus has poles that experience 42 years of constant sunlight, then 42 years of complete darkness. The seasons are very different, strange, and not completely clear yet. Picture one half of a planet soaking up sunlight for many years, then suddenly entering a long period of darkness. Even so, the planet looks strangely similar all over a round ball of soft blue, without the noticeable storms and bands seen on Jupiter or Saturn. The soft blue color is due to methane gas in the upper atmosphere, which takes in red light and reflects blue light. Under that cloud layer is a cold and complicated world. Uranus is known as an ice giant, which is different from gas giants like Jupiter or Saturn. It has hydrogen and helium layers on the outside, but inside it is mostly made up of ices like water, ammonia, and methane. This creates a thick, slushy layer that could go on for thousands of kilometers. Uranus probably has a small rocky center, but there is still a lot we don't know. Uranus gives off very little internal heat, which is different from the other giant planets. Saturn and Jupiter give off more energy than they get from the Sun because of the heat that remains from when they were formed. Uranus, on the other hand, hardly emits any extra energy. The planet's internal engine seems to have stopped working. What is the reason? It's uncertain. One common idea is that a huge crash happened early in Uranus's life, maybe with a big planetary embryo. This impact might have tilted the planet, disturbed its insides, and made it lose a lot of its original heat. The outcome is a planet that is always tilted, frozen, and full of mystery. Even though it's about 1.8 billion miles, 2.9 billion kilometers away from the Sun, Uranus has a surprisingly intricate magnetic field. However, similar to other aspects of the planet, it goes against the usual expectations. The magnetic field is not aligned properly with the planet's rotation and is also off-center from the planet itself. As Uranus rotates, it creates an uneven and wobbling magnetic field that is unique compared to others. Next, we have the rings. Yes, Uranus has rings just like Saturn does. They are darker, thinner, and harder to see, made mainly of large particles and dust. So far, 13 have been confirmed, and they are believed to be quite young and energetic. Some of these rings are guided by small moons that help keep their shape, a gravitational interaction happening in almost complete darkness. Uranus has 27 known moons, which are mostly named after characters from Shakespeare and Alexander Pope's works. These include Titania, Oberon, Ariel, Umbriel, and Miranda. The moons have different types of rocks and ages, and some, especially Miranda, show evidence of a lot of activity in the past. Miranda looks like a mix of different landscapes, as if it were broken apart and put back together in a messy puzzle. Voyager 2 is the only spacecraft that has visited Uranus, and it did so in 1986. In one quick sweep, it collected as much information as possible, showing the planet's basic features, rings, and magnetic field. That meeting was short. Since that time, Uranus has mostly been left alone, waiting in the shadows for a mission that never happened. Recently, Uranus has gained attention again. Scientists see it as important for understanding ice giants, exoplanets, and how planets form. Many of the planets we've found in other solar systems are about the size of Uranus. In our own system, we have only just begun to explore what it is, how it came to be, and what mysteries it contains. A focused mission to Uranus, likely in the 2030 seconds, is currently being taken into serious consideration. Uranus might not grab your attention with rings like Saturn or storms like Jupiter. Its unusual features, unique rotation, and the mysteries it holds make it one of the most interesting places in the solar system. Beyond it is a planet that is even colder, stormier, and more powerful, with winds that move faster than sound. In Neptune, the Dark Wind, we explore the last giant of the solar system, a place where blue is everywhere, and there is always movement, the Dark Wind. A dark blue ghost in space, covered in storms, rotating with the quickest winds in the solar system. Neptune is the planet that is the farthest away from the Sunday. On the other side, there is just ice, rock, and the quiet of space between the stars. Neptune was found in 1846, not by looking at it directly, but through math. Its pull on Uranus showed that it was there before a telescope confirmed it. This made Neptune the first planet discovered through prediction. Since that time, it has held on to its secrets. Neptune is about 2.8 billion miles, 4.5 billion kilometers away from the Sun, and is a planet with extreme conditions. The Sun looks more than 900 times less bright than it does from Earth. Temperatures drop to around negative 373 degrees Fahrenheit, negative 225 degrees Celsius, only a few degrees above absolute zero. Despite the cold and distance, Neptune is still active. This planet is full of activity, making a loud noise, turning around, and very angry. Neptune, like Uranus, is an ice giant. It mainly consists of water, ammonia, and methane ices surrounding a rocky core, all covered by a thick layer of hydrogen and helium. Neptune gives off more than double the heat it gets from the Sun, thanks to an unknown internal source that has been active for billions of years. Why this heat exists and why Uranus doesn't have it is still one of the biggest mysteries in planetary science. Neptune is a deep sapphire blue, which is richer than Uranus. Both planets get their color from methane in their upper atmosphere, which absorbs red light and reflects blue. Neptune's atmosphere is much more active. In 1989, the Voyager 2 spacecraft, the only human probe to visit, took pictures of a huge storm known as the Great Dark Spot, a swirling vortex as big as Earth. Although it later went away, similar dark spots have been seen by the Hubble Space Telescope, appearing and disappearing in Neptune's changing atmosphere. These storms are not quiet. Neptune has the fastest winds in the solar system, with speeds exceeding 1,300 miles per hour, 2,100 kilometers per hour. That's almost 2 times faster than a commercial jet and quicker than the speed of sound on Earth. The winds blow strongly around the planet's equator, creating white clouds made of methane ice that move through the atmosphere like fiery streaks of cirrus clouds. Under the clouds, Neptune's inside turns into a slushy blend of water and unusual ices. Deep in the mantle, there could be diamond rain carbon atoms pressed into crystals by great pressure, gradually moving down toward the core like valuable hail. If this is correct, Neptune might be a real gem of the solar system, shining brightly from within. Neptune has a faint set of rings around it, which were first suggested in the early 1980 seconds and later confirmed by Voyager 2. These rings are dark, dusty, and not fully formed. They look like uneven arcs instead of smooth circles. They are weak and unstable, probably affected by the gravity of Neptune's many moons. Neptune has 14 confirmed moons, and one of them, Triton, is very interesting. In our solar system, Triton is the biggest moon of Neptune, and it stands out from all the others. It orbits in reverse, moving the opposite way of Neptune's rotation. This indicates that Triton may have originally been a captured object, likely a dwarf planet or a body from the Kuiper belt that Neptune took from the outer solar system. Triton is a cold and ancient moon that is still geologically active. It is one of the rare places outside of Earth where we have seen cryovolcanoes. Voyager 2 saw geysers of nitrogen shooting up from its icy surface, going as high as 5 miles into space. Triton's surface has a mix of ridges, flat areas, and bumpy terrain that looks like cantaloupe. This unique landscape is formed by both impacts and forces from within the moon. Triton has a thin atmosphere that is mostly nitrogen, and it might become thicker when Triton moves closer to the Sun during its long 165-year orbit. Even though Neptune is the last of the big planets, its story is still ongoing. Voyager 2's quick visit raised many questions that remain unanswered, and no spacecraft has come back since then. The planet has strong winds, heat inside, a diamond core, and a wandering moon that need more research. Planetary scientists really want a mission to Neptune, which could include an orbiter and a lander for Triton. Neptune is a symbol of the solar system's distant edge, far away, not fully understood, but truly impressive. It shows us that even in bright light, energy can still find a path to travel. Beauty can appear even in the bleakest places. The outer planets are not just cold places, they are lively worlds filled with storms, moons, and movement. Pluto and the Kuiper belt, mysterious objects beyond Neptune. The faraway world lost its place, a place not yet found where icy remnants float in the dim light of our solar system. Pluto used to be the 9th planet. For many years, students learnt its name as the last place we visit in our exploration of the solar system. In 2006, everything shifted. The International Astronomical Union changed the definition of a planet, which led to Pluto being classified as a dwarf planet instead. The decision caused anger, discussion, and sadness. How can a planet be taken apart? The answer is not found in politics, but in the increasing complexity of the area where Pluto is located, the Kuiper belt. Pluto travels around 3.6 billion miles, 5.8 billion kilometers away from the Sun, in an area filled with icy objects beyond Neptune. This area, named after the astronomer Gerard Kuiper, contains thousands, maybe even millions, of frozen objects that are remnants from the formation of the solar system. These objects are tiny, chilly, and dim, moving in long, stretched-out oval paths. They create a second asteroid belt, which is much colder, wider, and more unusual. Pluto is one of the biggest objects in the Kuiper belt, and it still deserves our attention. With a diameter of only 1,477 miles, 2,377 kilometers, it is smaller than Earth's moon, yet its surface is incredibly varied. For many years, it appeared as a fuzzy dot in telescopes, until NASA's New Horizons spacecraft passed by in July 2015, providing the first detailed view for everyone. What it observed was surprising. Pluto is not just a lifeless rock. This world has a lot going on with its icy flat areas, tall mountains made of water ice, and signs of ice, volcanoes. One of its most well-known features is Sputnik Planitia, a large heart-shaped area made of frozen nitrogen that might hide an ocean beneath its surface. The surface has bumps, dips, and moving glaciers, evidence that Pluto's inside is still warm enough to change its outer layer. Pluto has a fascinating atmosphere made up of a thin layer of nitrogen, methane, and carbon monoxide that stretches for hundreds of miles above its surface. As Pluto travels away from the Sun in its 248-year orbit, its atmosphere slowly freezes and falls to the surface, then comes back as it gets closer again. Pluto takes slow, cold breaths. Pluto has 5 moons, and the biggest one is Charon. Pluto and Charon are so large that they are sometimes seen as a binary system. They orbit around a center of gravity that is outside of Pluto. Charon has a dark and rough surface featuring canyons and cliffs that suggest it experienced violent events in the past. The smaller moons, Nix, Hydra, Kerberos, and Styx, move around in an unpredictable way, influenced by the unusual gravity of this faraway pair. Pluto has company. It is one of many icy worlds, and some of them make us rethink what we know. In 2005, astronomers found Eris, a KBO that is larger than Pluto. This finding started the discussion that eventually resulted in Pluto being reclassified. Since that time, more have been discovered. Haumea is shaped like a football and spins quickly. Makemake is bright and far away, covered in frozen methane. Sedna has a huge orbit that takes more than 11,000 years to go around the Sunday. These dwarf planets are leftovers from the early solar system, not affected by the heat and disorder of the inner areas. Their presence shows us that the solar system goes beyond Neptune. It stretches into a large, icy area full of old mysteries. It might go even further. Some astronomers think there might be a large, hidden planet beyond the Kuiper Belt called Planet 9. Scientists think there's something big out there because of the unusual paths of faraway KBOs, as if a large object is guiding them from a distance. There is no clear proof yet, but the search is underway. If Planet 9 is real, it would be a large planet, either a super-Earth or an ice giant with a mass 5 to 10 times that of Earth, orbiting about 20 times farther from the Sun than Neptune. If discovered, it could change everything we believed about the farthest part of the solar system. The Kuiper Belt, which was once hidden and not well understood, is now a key area of interest in planetary science. Missions such as New Horizons are only the start. New plans for probes, including orbiters for the Kuiper Belt, and missions to return samples are coming soon. These icy places might provide answers to some of our oldest questions. How did planets come into existence? What materials make up Earth? Can life start in places much colder than we thought possible? Pluto might not be called a planet anymore, but it has sparked more interest than any other world since Mars. Its demotion marked the start of a new chapter, not the end of its story. The Oort cloud and the Sun's edge, a frozen group of comets, a ring of old ice where the solar system quietly ends before disappearing into space. The solar system is not organized in a tidy way. The journey doesn't stop at Pluto, Neptune, or the Kuiper Belt. These well-known names are just the inner parts of a much larger system, one that extends light years from the Sun's heat. Out here, space feels unique, calm. At the farthest point, there is a large, round area called the Oort cloud. The Oort cloud is named after Dutch astronomer Jan Oort, who suggested it might exist in 1950. However, it has never been seen directly. No telescope has captured an image of it. No spacecraft has arrived there. Its fingerprints can be found all around us, particularly in the paths of long-period comets. These icy bodies come from all directions, appearing unexpectedly, and orbit the Sun on paths that take tens of thousands or even millions of years. These comets carry messages, hints. They suggest that there is a layer of material around the solar system, similar to a cosmic snow globe. The Oort cloud is believed to start about 2,000 astronomical units from the Sun, which is 2,000 times the distance from Earth to the Sun day. It may stretch out to around 100,000 AU, almost 1 light year away. It might have trillions of icy objects, which are leftovers from the solar system's creation, pushed away by the gravity of the large planets during the early stages of forming planet. Picture this: a group of comets moving in all directions, unlike the flat spinning disk of planets, but forming a three-dimensional halo. These objects are far away, very cold, and not bright enough for us to see. Sometimes something pulls you in like a passing star, a gravitational wave, or the tidal forces of the Milky Way. When that happens, the comet starts a long journey that can last thousands of years. It slowly moves toward the Sun, passes through the inner solar system, brightening our skies before heading back into the darkness. Comets like Hale-Bopp, Hyakutake, and comet Neowise are believed to come from the Oort cloud. These aren't ordinary visitors like Halley's Comet. They are unique events, possibly never to come back in a person's lifetime. The Oort cloud is not only beautiful, it shows the real limit of the Sun's effect, not by gravity, but by material. Outside this halo, the solar system leads into interstellar space. The particles in the Sun's solar wind stop pushing outward. They are balanced and then overwhelmed by the pressure from the galaxy. The heliopause is the boundary that marks the end of the Sun's influence. It is much nearer than the Oort cloud, about 120 AU from the Sun. This is the point where the solar wind stops as particles from the Sun encounter the charged gas of interstellar space. The Voyager 1 and 2 spacecraft have crossed a boundary, becoming the first human-made objects to leave the Sun's protective bubble and enter the space between stars. Voyager 1 was launched in 1977 and is now more than 14 billion miles away from Earth. It keeps sending data, moving through space, with the golden record a message from humans in sound and pictures, meant for any life that might find it in the future. Voyager is now our representative in space. In the Oort cloud, everything stays frozen. Some comets might have originated in the same area as Jupiter and Saturn, but were then thrown out. Some could be visitors from other stars that got caught by the Sun's gravity a long time ago. The cloud might be the leftover bits from when the solar system was young and chaotic, a collection of materials that never turned into planets, moons, or asteroids. Maybe the Oort cloud is not the only one of its kind. Other stars probably have their own clouds of comets, large, unseen spheres floating through the galaxy like seeds in the breeze. The Oort cloud is not only the edge of our solar system, but also the start of the larger story of the galaxy. Where does our solar system stop? It's not at Neptune, not at Pluto, not even close to the Oort cloud. The reality is, it never really stops. Its gravity extends endlessly. The particles move past the heliopause, comets go up and down, the light reaches other stars. Our solar system's story connects to the Milky Way's story, and eventually to the universe as a whole. In the next and final chapter, we pull back really far back to view the solar system not just as a group of planets, moons, and dust, but as one whole, connected being. A fragile home among the stars explores the beauty, violence, and poetry of the solar system and what it means to live there. A delicate house in the cosmos, a space filled with extremes of heat and cold, creation and destruction, and one tiny planet where life began to marvel. The solar system looks normal from far away, one of billions spread throughout the Milky Way. Its star isn't very bright, the planets are not very big, its moons are not very uncommon. To us, It means everything, our beginning, our foundation, our place. It started in disorder with the breakdown of a molecular cloud, maybe caused by a nearby supernova. During that collapse, the sun started to burn, planets were formed, moons were created. The oceans are full. Comets fell like seeds in the empty space. From this cosmic dust, order emerged. From that order, time, and over time, life. The solar system is not just a list of planets. It is a large, connected interaction of gravity, chemistry, and luck. It is a very old and accurate machine. The paths of its planets are very steady and could last for billions of years. Even with that structure, there are surprises, changes, movements, transitions. It isn't a flawless machine. It is alive. In that perfect balance, not too hot, not too cold, not too big or small, Earth came into existence. It circles the sun at the perfect distance, has a magnetic field for protection, contains water and carbon, and is accompanied by a moon that helps keep its spin steady. It all feels unlikely. And still, here we are. We looked up from Earth and gave names to the stars. We tracked how the planets move. We shared stories about them. Mars was known as the god of war, while Venus was recognized as the goddess of love. Saturn signified the flow of time, while Jupiter governed the skies. By naming them, we aimed for something bigger, a spot in the universe. But science revealed the truth that these were not gods, but worlds. Some are dead, some are alive, some are still changing. In that moment, we understood something important. Earth is not the center, but just one of many. A light blue speck in a vast expanse of dust and flames is quite a dot. Earth is the only place we currently know of that has life. It is the result of many random events, like the angle of its axis and the arrival of water from old asteroids. Life started, changed over time, and eventually became curious enough to create telescopes, spacecraft, and ask questions that are too big for just one lifetime. We have explored nearly every part of our solar system. Humans have walked on the moon, rovers were sent to Mars, passed by every planet, we landed on comets, collected stardust, and got to the edge of the sun's wind. Our machine sends signals from billions of miles away, still calling our name in radio waves. There's still more to find out. Every world we explore shows us something new about rocks, chemicals, and air. It also helps us learn about who we are. The storms on Jupiter give us information about weather. Venus alerts us about climate issues. Mars demonstrates the effects of a planet losing its water. Earth is delicate and full of life, showing us just how special and valuable life really is. The solar system is more than just our home. It is a reflective surface, a device that allows travel through time, a person who teaches, a book of stories. It holds our history, our future, and the basic building blocks of our bodies. One day, we might go away from it. We might create ships that can travel to Alpha Centauri or even farther. Wherever we go, we will always have the mark of this system with us, the force of its gravity, the warmth of its star, and the memory of its blue planet. This is more than just the solar system. This is where I live.